Hello viewers, this is Waragada Ronald taking you through today's tutorial on application of differentiation 1. And today's lesson we are going to talk about small changes in calculus. So we have seen that as small change in x tends to 0, small change in x, small change in y tends to dy dx. What does that mean? It means that if this is small, then small change in x, small change in y approximates to dy dx. And when we make small change in y the subject, we shall come up with this expression, which is small change in y being approximately equal to dy dx multiplied by small change in x. Now this is the expression we shall use in this video. So there are three applications for this formula, and one of them is determining the nth root of a number. For example, square root, cube root of a certain number like that. Then two, small increment or decrement in a quantity. For example, increase in volume, increase in area, increase in height. And lastly, error in measurement. For example, error in measuring the area, error in measuring the volume, and error in measuring the height, etc. So we shall start with one, which is determining the nth root of a number. So let's start with this problem. Using calculus or small changes, show that the 50th root of 224 is equal to 3 whole numbers 1 over 405. So in this case, we shall realize that this 3 and 1 over 405 is between two integers, and that is 3 and 4. So we shall look for the value which is closer to this value. So since they want 50th root, it means this power 5 will be 243, and 4 to power 5 will be 1024. If you look at these two values, it is this one which is closer to 244, therefore we shall take that. And in this case, we shall say that to get 224, we had to say 243 plus 1. And in this case, it means that this is now our x, and this is our small change in x. And everything will be equal to y plus small change in y. Like we said. So now that we know x, it means that y is equal to x power 1 over 5. And therefore, x we already saw it as 243. Therefore, the 5th root of 243 is equal to 3. So that is our value for y. We have now got y, and now our task is to get small change in y. To get small change in y, we have to first get dy dx. So y is this, therefore dy dx will be bring down the power, which is 1 over 5, reduce the power by 1, you will say 1 over 5 minus 1 to give you negative 4 over 5. When you substitute for x, we shall get this, and when you use the calculator, we shall come up with 1 over 405 as our dy dx. And from the formula for small change in y, we shall say small change in y approximates to dy dx multiplied by small change in x. I know dy dx is 1 over 405, and small change in x is 1. So in the end, I'll come up with 1 over 405. But I remember this is equal approximates to y plus small change in y. Now that I've got y and I've got small change in y, I'll just substitute and say y will be 3 plus small change in y, which is 1 over 405, and in the end I'll come up with 3 whole numbers 1 over 405, which was required. Then problem 2, they want you to use calculus or small increments or otherwise to find the square root of 98 correct to 1 decimal place. So in the previous question, we are given a proof and we are able to estimate where the value lies. But now in this case, we are not given any proof. So the first thing to do is to use the press your calculator. Square root of 98 is what? It will give you 9.899494935 using a calculator. So that helps us to know that the square root is between 9 and 10. So I'll come and say 9 squared is 81, 10 squared is 100. So that, what does that mean? 98 is closer to 100. Therefore, we shall take our x as 10. When we take our x as 10, we shall get 9. It means that 98 was got by saying 100 minus 2. And therefore, we shall now use subtraction because of this subtraction. Therefore, this is our x and this is our small change in x. Therefore, the square root of 98 will be equal to y minus small change in y. So we know x, we know small change in x. Next will be to substitute for y to get the value of y. We know that x is 10, x is 100, therefore 100 will be here to give you square root of 100 will be 10, and that will be the value for y. And dy dx, remember, to get small, now that we have got small change, we have got y, to get small change in y, you have to first get dy dx. So I'll come and differentiate y to get this. So this is the same as x to power a half. When you bring down the power, it will be a half. Reduce the power by 1, it will be a half minus 1 to give you negative a half. When you substitute for x, you'll come up with 0.05 as dy dx. Then you come and substitute in the formula. Small change in y approximates to dy dx multiplied by small change in x. I know dy dx is 0.05, and my small change in x was already got as 2. So when I substitute, I'll come up with small change in y as 0.1. Therefore, now that I've got y and I've got small change in y, I can get the square root of 98 being approximately equal to y minus small change in y. My y was 10, which is this, and small change in y is 0.1, which is that. When I use a calculator, I come up with 9.9, and that would be the square root of 98. Now we shall go to problem 3. Problem 3 says that using mathematics of small changes, show that sine of 30.5 degrees squared is approximately equal to 180 plus pi root 3 everything divided by 720. So in this case, first of all, we know that 30 degrees is a particular angle. Particular angles include 30, 45 and 60. So for this case, we shall use 30, which is closer to 30.5. Therefore, sine squared of 30.5 degrees is equal to sine squared of 30 degrees plus 0.5. What does that mean? It means that now 30 will be x and 0.5 degrees will be small change in x. So x is 30 degrees and small change in x is 0.5 degrees. Now, because small angles are well measured in radians, we shall convert this 0.5 degrees to radians. How do you convert? We shall multiply this 0.5 degrees by pi over 180, and in the end we shall come up with pi over 360 radians. So small change in x is equal to pi over 360 degrees radians. And because the whole of this is y plus small change in y, it implies that y alone will be equal to sine x. So y is equal to sine squared x, and I know that x is 30, so I'll come and substitute sine squared 30. But I know that sine 30 is a half. So when I square a half, I'll come up with a quarter, which is 1 over 4. Now that I've got y, I'll come and differentiate to get dy dx. So dy dx will be equal to 2 sine x cos x, and I know that this is an identity of double angles, and the whole of this will be equal to sine 2x. But I know that x is 30, therefore sine 2x will be 60, which is this. Remember, we substitute after differentiation. Now sine 60 is also a particular angle, and sine 60 is the same as root 3 over 2. Now that I've got dy dx, I'll come and get my small change in y from dy dx multiplied by small change in x. dy dx is √3/2, so I'll come and substitute for dy dx. Then small change in x was already got as pi/360, so I'll substitute for small change in x, and when I use the calculator, I'll come up with pi√3/720. From there, I'll now say that my sine squared 30.5 degrees is approximately equal to y plus small change in y. My y is 1/4 and small change in y is pi√3/720. When you get the LCM, it will be 720. So this divide by 4, it will give you 180 times 1 to give you 180. Then this divide by this, it will be 1. Then 1 times this to give you that. And when you compare, it will be the same as the required proof. So that's how they use mathematics of small changes to get sine squared 30.5 degrees. Now we shall go to small increments stroke decrements in a quantity. And we shall start with this problem. So problem 4 says the surface area of a sphere is 4 pi r squared. If the radius of the sphere is increased from 10 centimeters to 10.1 centimeters, what is the approximate increase in surface area? So we are given the formula for surface area, and this denotes r. So r is 10 centimeters, small change in r will be 10.1 minus 10 to give you 0.1. Area is 4 pi r squared as it was given in the question. Before we substitute for r, you have to first differentiate. So I'll come and differentiate a to get the ADR being equal to 8 pi r. So now that I've differentiated, I can substitute for r. My r is 10, so I'll come and substitute to get 80 pi as the ADR. Having got the ADR, I can now get small change in a from the formula the ADR multiplied by small change in r. The ADR is 80 pi and small change in r is 0.1. Therefore, my small change in a or area will be 8 pi centimeters squared. So this will be the small increase in surface area. So now problem 5 says that one side of a rectangle is 2 times the other. If the perimeter increases by 2%, what is the percentage increase in area? So let x be the smallest side of the rectangle. It means that x will be the smallest side and the other side will be twice this, which is 2x. The perimeter will be 2 plus L plus width. So L is 2x and width is x. So 2 plus that will give you 6x. Now that I've got perimeter in terms of one variable x, I can now differentiate. So when I differentiate, I'll get the pdx being equal to 6. Therefore, the area in the perimeter will be given by, remember we are given the percentage area in perimeter, so the area will be that percentage of 2/100 multiplied by the total perimeter, which is p. And p is 6x, therefore I come and substitute for p to get 0.02 times 6x to give you 0.12x. So this is now the area in the perimeter. For area, we shall say area is equal to length times width. Length is 2x and width is x. So 2x times x, I'll get 2x squared. Therefore, now that our area is in terms of one variable, I can easily now differentiate. So differentiating will give me the ADX being equal to 4x. So now I can use chain rule, the ADP being equal to the ADX multiplied by the XDP. Now the ADX is 4x and the XDP is the reciprocal of the PDX. The PDX was 6, therefore the XDP will be 1/6. When I simplify, I'll come up with 2x/3. Now that I've got the ADP, I can now get small change in area. from the formula that the small change in area approximates to the ADP multiplied by small change in P. My ADP was 2x over 3 and small change in P was 0.12x. When I multiply, I'll come up with 0.08x squared. Now the question wants percentage increase in area. Remember, percentage increase in area is the same as increase in area over total area multiplied by 100%. So increase in area is 0.08x squared, which is that, and the total area is 2x squared, which you already saw, multiplied by 100%. You come, this x will cancel, and this will give you 0.04. Now 0.04 multiplied by 100 will give you 4%, and that will be the percentage increase in area which is required. So now we shall go to error in measurement. So we shall start with problem 6. It says an error of 2.5% is made in the measurement of the area of a circle. What percentage error results in Roman 1, the radius, and Roman 2, the circumference? In other words, they want the percentage error in radius and also the percentage error in the circumference of the circle. Now let r be the radius of the circle. What does that mean? It means that this will be the radius, this will be the circle, and the percentage error in measurement of the area is 2.5%. Now know that area of a circle is given by pi r squared. I think you can see that now for this case the area is in terms of only one variable. Therefore we can go ahead to differentiate to give us the ADR being equal to 2 pi r. And I know that the small change in area, remember I was given the percentage error in area which is 2.5%. Therefore percentage error in, the error in the area will now be the percentage, which is 2.5 over 100 multiplied by the total area, which is A. I know my A is it's pi r squared, so I come and substitute to get 0.025 pi r squared. And now that I know small change in A, I'll come and say small change in r, which is the error in the radius, will be equal to the r dA multiplied by small change in A. Now the r dA is the reciprocal of the a dr, which is 1 over 2 pi r. And my small change in A is this, which I'll come and substitute for small change in A. When I use the calculator, I'll come up with 0.0125 r. The percentage error in the radius, which is small change in r, will be given by small change in r over r multiplied by 100%. So my small change in r is 0.025 r over the r to give me this, and after that I'll multiply by 100 to get 1.25%. Now shall go to part B, where they want the small change, the small change in circumference, or the error in the circumference. Now know that the formula for circumference is given by 2 pi r, and in this case this circumference is expressed in terms of one variable, which is r. Therefore we can go ahead to differentiate. When I differentiate, I'll get the CDR being equal to 2 pi, and therefore small change in C will now be equal to the CDR multiplied by small change in r. My DCDR is 2 pi, so I can substitute for the CDR, and small change in r was got as 0.0125 r. When I multiply the two, I'll come up with 0.025 pi r as my small change in circumference. But remember, they want the percentage error in the circumference. So I come and say that percentage error in circumference is equal to error in circumference over total circumference multiplied by 100. So my small change in C was 0.025 pi r. So I come and substitute for small change in C, substitute for C, and multiply by 100. In the end, I'll come up with 1.25 as my percentage error in circumference. So we have gone through a number of problems. It's now your turn to try out these problems. So that is problem 1. It is a proof. That is problem 2. You compare answer with this. That is problem 3. Compare answer with this. So that is problem 4. Compare answer with this. That is problem 5. You compare answer with this. So that has been our lesson for today. Thank you for watching, and please subscribe to my channel, Rowa e-learning platform. Thank you.